Hello and welcome to the second in a series of videos on systems thinking. My name is Bhaskaran and I'm going to walk you through this series. In this video, we're going to be looking at certain characteristics of a system and what makes up a system. Because without understanding these characteristics, it is difficult to conceptualize a system of your own. Let me start with an example. Suppose I were to ask you the address of your house or your office. What are you typically likely to do? You're going to give me a door number, you're going to give me the name of a street, the name of a locality, and the name of a city. Bangalore, Chennai, Hyderabad, etc. And if you are sending this internationally, you're going to say India. And in your mind, you know that the postal authorities are going to deliver this address to India in Bangalore or Chennai or Hyderabad at this door number, at this street, at this location. You never would say, for example, India, Asia, the Earth, the solar system, the Milky Way. You don't say that. You stop with the name of the country. In your mind, you have created a boundary which is enough to understand the system. And in this case, that system is the address of your house. So let's look at some of the characteristics of a system. And we should, by the end of this video, be able to define the 5 main characteristics of any system. The formal, the official definition of a system is that it is a group of interacting, interrelated, and interdependent components that form a complex and unified whole. So let's look at each of these words. They mean a lot. Interacting means that the subsystems interact with each other, with one or more of the other subsystems. Interrelated means that the subsystems are related to each other in some form or the other. Interdependent, obviously that the subsystems are dependent on each other to behave and to create the characteristics of that system. There are 2 other interesting words here. It says it's a complex and unified whole. That's pretty obvious. When you put all these subsystems together, the overall system becomes much more complex. But on your screen, you'll also see the word emergence. And the best way to explain this is like this. This has been the classical explanation all along. Suppose you were to take 2 atoms of hydrogen and an atom of oxygen. You combine them together, you get H2O, which is water. Now, water has a characteristic called wetness. So, water does feel wet. But neither hydrogen nor oxygen in themselves are wet. Emergence is the characteristic of the system that is different from the characteristics of each of the subsystems. And until these subsystems come together, they interact and they are interrelated and they are interdependent, you do not get the emergent quality of the overall system. This is the formal definition of the word system. Characteristic number 1. Every subsystem has a purpose within the larger system. So, for example, if you take the human body, which is by far one of the most complex systems, every subsystem, a finger, my lungs, my heart, has a function within this system called the human body. So, every subsystem has a function within the larger system. Characteristic number 2. All of the system's parts must be present for the system to function. So, for example, I cannot be walking around here without my lungs. I've left it at home, I'm coming back tomorrow to pick it up. No, doesn't work. The human body requires all of its parts to function like a human body would. This is characteristic of whether it's an animate system or an inanimate system. Characteristic number 3. A system's parts must be arranged in a specific manner. If any of you have seen horror movies, typically the villain of the movie has some parts that are kind of misaligned. And as a human being, we recognize that that system is not organized properly. Similarly, if you were to take an architectural marvel like the one on your screen, this system, this architectural marvel would collapse if any one of those pillars were not standing at precisely the location that it is today. This is really what defines a system. If you were to change those pieces around a bit, and if it was still stable, you would form a system, but it would be a different system. That's why characteristic number 3 is so important. All subsystems of a system must be arranged in a specific way for the system to behave the way it does. Characteristic number 4, systems change in response to feedback, and this feedback can be of any form. For example, on your screen there is Mother Earth in flames. What I'm trying to get at is, of course, global warming. Now, Mother Earth is a large system, a huge system, and yet Mother Earth is adjusting itself to the pollutions and to the changes in the climate that we see happening today. So Mother Earth is forced to respond to feedback coming from other factors within the system. This is what characterizes a system from itself. It must respond to feedback to achieve a new state of stability. The last characteristic of a system, characteristic number 5, is that a system maintains its stability by making adjustments based on these feedback. So not only does it respond to feedback, but if the system is to persist, it must readjust itself such that stability is re-established. Otherwise, the system would collapse on itself and it is no longer the system that we are talking about. In summary, these 5 characteristics define a system. So if you were to look at understanding a system and at defining a system, you must try and identify these 5 characteristics as we just spoke of. Every subsystem has a purpose within the larger system. All of a system's part must be present. All the parts must be organized in a specific way. The systems will change in response to feedback, and the system tries to re-establish stability based on this feedback. I hope this gave you a flavor for what and how you ought to define systems. We will give you more examples of this as we go along. Until then, I would urge you to read a little bit more about these concepts, and there's plenty of material out there. Thank you very much.